we're going to look at functions in Python. So generally you want to use a function in Python if you have a section of code that you're going to be executing repeatedly. So if you wanted to say print hi, if you wanted to say print hi repeatedly, of course you could just print that repeatedly. So let's say print hi again, and you could execute that. But if you wanted to execute that repeatedly, you could just duplicate that, copy and paste it, of course, and now it'll just repeat that. Or, if you wanted, you could make a function that you could call to repeat that functionality. So a function is a section of code in Python where you have a set of instructions You can see I've defined this function first by using the def keyword, which just stands for define, and then using the name of the function. In Python, there are rules for naming the function, just like there are rules for naming a variable, and there are also conventions. Here I've used camel case with a lowercase first letter and then an uppercase for each letter for an additional word. It's more conventional in Python to use a lowercase all the way across and then an underscore between words, but I didn't want to. Then we have parentheses for reasons that we'll see in a little bit, and then a colon. In Python, a colon usually indicates that there's a block of code that's following that all goes together. Here we specifically indicate a block of code with its white space, its indentation. And that's how you do it in Python. So instead of having curly braces like you do in Java, you use the white space. Here I've indented by one tab. Different organizations have different house styles, whether it's 4 spaces or 2 spaces. One tab is what I'm using here. In any case, the white space has to match for each block of code. So these two lines each have a white space indentation of one tab, so they all go with the definition of the function. When I go all the way back to the left-hand side, I'm now outside of that block of code, and I'm outside of that function. Now, so far, my function is defined with a set of instructions, and so as the interpreter goes through, it will store those sets of instructions in this defined function that I'm calling say hi, but so far, nothing happens. So what I need to do now is tell the program to actually run that function. And now it executes that function, right? And I can duplicate just that function command, and every time I execute it, it runs all of those lines of code, all 2 of those lines of code, right? So this is useful because we know one of the principles of computer science is don't repeat yourself, right? So this is an excellent way to have a segment of code that might be repeated, otherwise compact in one location. Now, sometimes you might want to have a function where you give it some sort of input and it can work with that input. So for example, let's say you wanted to say hello to a particular person. So let's say you wanted to say hi, Samuel. And so we can say hi. You might also wonder why these parentheses are here. We're getting there. So say hi, Samuel. That's fine. But if you wanted to say hi to a different name every time, well, Samuel is hard-coded into this line, so we're not prepared to say hi to different people. So what we would like to do is to put a name in this place. And we need to pass a name into it. So we could just put Samuel in here. But now, again, the name Samuel is going to repeat every time we execute this command. So what we'd like to do instead is give it a name. And so we can put name in the parentheses. This has become a parameter. Now, when we call this function, we can give it a name, such as Samuel, or Rita, or Johansson. Right? And now every time this function is called, it will store a different string into the variable name, and then inside the method, it will retrieve the variable that was stored in that parameter in order to execute it. Okay. We might have more than one parameter inside our function. So let's say we have another function. Let's get rid of these. And we want to multiply two numbers. There's no reason to define a function to do this, but let's just say we want to. And so we have num1 and num2. Okay? And we would like to print the outcome. So we're going to say print num1 times num2. Okay. Now, first of all, if we just run this with no arguments, we're going to have an error because the function is looking to have two arguments in these positions. So we need to make sure that we have arguments there. So let's put in 2 and 8. And now it prints the output, which is 16, which is what we told it to do. We can do this with reals as well as integers because Python is dynamically typed. But let's see what happens when we do a string. Python also has an operator that looks like the multiply symbol for strings. And you saw what happens is that it just repeats the string whatever number of times the number out front is. So if we have an integer and a string, we still get something executed in this line. Might not be what we want, but it's something. But if we have a real and a string, at this point, Python doesn't know how to interpret these, and so we get an error. So we can have a function, and we can have 0 parameters, we can have 1 parameter, we can have basically as many parameters as we want to pass. Basically as many parameters as we want to pass in as arguments. Now, there's something pretty handy we can do here as well. Let's go back to our say hi command, or say hi function. And let's say that we wanted to constantly be saying hi to people. So we say hi to Tuan, and then we say hi to Abdul, and then we want to say hi to Samuel like 10 times. There's a better way to do it than what I'm doing right now, but there. I don't think that's 10, but it's something. So we could type in Samuel each one of these times before I duplicated it, which is fine and probably a reasonable way to do it. But we can also prepare what's called a default in the parameter. And what a default allows us to do is if we have a value for name that we pass in as our argument, that value will be stored in name. just like it did before. So let's get rid of all these say hi's down here and just execute it. We got what we expected before. It goes, stores in names, comes out in the output. But if we have another say hi, and this one doesn't have any arguments, there's nothing to be passed into name from outside the function call. Well, now it will go to its default value and say hi to Samuel. And we could put in defaults into any sort of function that we want to define. So those are the inputs into a function. There are times we want the output of a function as well. In fact, we probably want to output the result of this multiplication rather than print it. We probably want to multiply two numbers and then do something with that product instead of just print it to the screen. So what we would frequently do is to return some sort of value. And so when a function gets to this keyword return, it's going to spit back out the value that comes after this return to the code that called it. So I'm writing more lines than necessary here, but we can set num1 times num2 as value and then return value. And so when we call this down here, we can say product is equal to mult, and then we'll say 4.5 and 7.9. Right? Now, if I just execute that, it happens the product has been assigned as the multiplication of 4.5 and 7.9, but we have no way of knowing that. It didn't happen to appear on the screen. So we would want to see that result up on the screen. So we can just print it there like that. Now, why is this any different than printing it inside the mult function itself? Well, what if we wanted to take that result, so we want to take the mult of 4.5 and 7.9, but then we want to multiply that by 9.8. Obviously, remember, we can just use the multiplication symbol. I know that, you know that. We're just playing with functions here, right? So we want to multiply that by 9.8 if only we had a function that could multiply things. So what we can do in a single line is to say multiply the output of the multiplication times 9.8. And then that will be the product that we want to store. So this is called composition. Sometimes I put a space here so I can clearly see where the parentheses begin and end. We have a function. That function has a return value, and then that return value is passed into the argument of another function. And then we do something with that return value. That outer function might not even have a return value. In this case, it does. Okay. And we can execute that, and it gives us some real number. You don't have to care too much about what that real number is. But I could have taken this return value from here, and I could have composed it into a different function entirely. So for example, I could have said say hi to mult of 4.5 and 7.9. This is a very unlikely name for someone to have. But we could then say hi to 35.55004. I assume that's an Android of some sort. But we could also remember how the multiply command works for strings. Say hi to John John. I live in the South. Some people might be named John John. So we have a function we can define it with several lines of instructions. Those instructions get executed in our script only when they are called in our script, not when they are first defined. And we can either just have it execute lines and then that's the end of it, or we can have it return a value. The last thing to briefly mention is that functions are very useful while you're gradually developing code. So let's say that I have a pretty complicated set of instructions that I want to gradually figure out how to do. So let's say that I am doing some kinematics from physics. So that is, I'm trying to figure out the motion of an object. So I have the initial position, I have the initial velocity, and I have the acceleration, and I have how much time has passed. And I want to maybe return the final position. Keep putting semicolons because of Java. So there's a whole equation for this. The equation would be x naught plus v naught times dt plus 1/2 times a times dt dot dot 0.5. That's the equation I would want to work up toward. But maybe I don't want to do all of that all at once. Okay? Maybe I want to do this one piece at a time and make sure that each piece is working before I continue to add more elements. So maybe I want to start only by having an acceleration and a dt. So I could say my x is equal to kinematics with an a of 6 and a dt of 2, and I want to say print x equals x, something like that, right? So I execute that, and I see if it works before I start adding in more components. So maybe I add in v next. So now I add in v times dt. This is really meant to be the initial velocity. And now I need to make sure I add in my new parameter because I've added a new parameter up there. So I'll say 1, let's say. And it would probably be good to compare these numbers to known values. But notice that this is 2 larger than the previous one, which makes sense because I now have an initial velocity of 1 times 2 should make it 2 larger than the previous one. And now I add an x naught plus into that, and then finally I can say let's just add a 10 to all that business and then execute it. Right? So all these pieces allow me to test each little increment. Of course, this is a simple example. Once your code gets more complex, more important it is to use incremental development, test each piece as you develop it. Probably more complicated components, you want to have each individual piece be a function, and then they pass their components to one another. You test each function separately with values you know the outcome